sled is sliding down a sloped hill. Sketch the free body diagram of the sled. So here's a hill, and here is our sled. So just like before, we have that dot right in the middle. I like to start with gravity. Gravity is going to be coming straight down. That's how gravity works. Force of gravity. Okay? There's going to be some friction. The friction is going to be opposite of the way that the sled is moving. Well, I would hope if you were sledding, you're going to be moving this way towards that direction. So we're going to have the force of friction opposing the motion. And we're going to have that normal force. Okay, that normal force is always perpendicular to the surface. So the normal force is going to be in this direction. So the normal force is going to have both a component in the x and the y. And if we needed to add these vectors, we'd have to find out how much in the x and y, like we were doing before when we were adding vectors. So that's where we're going next. You'll notice I didn't put a force applied. Generally, to slide down a hill, you don't need a force applied. Sometimes you will get a push, but normally the push will be, if you're at the top of a hill, the person will push this way, right? Maybe they'll push that way. I don't know. But we're going to assume in this case that there was no force applied. It doesn't say you were pushed. It said it's sliding down a hill. Okay, so here's a free body diagram of a sled going down a hill. We don't know anything about the relative lengths of force normal, force gravity, force of friction, because it's moving and it's accelerating, right? So they're not going to add up to be zero. That's why you sled, is because you accelerate down the hill, and that's what makes it fun. So we don't know anything about the lengths.